That's it. We're alive. Hello, everyone.
Hi everyone, welcome to our first GPU audio video live stream. We're so excited to have you all here. My name is Anouk, and I'm the marketing manager at GPU Audio. And today we're going to be joined by Sasha Talashov, who is the GPU Audio co-founder and managing partner. Hi, Sasha. And
Hi,
Jonathan
everyone.
Rowden, who is GPU Audio co-founder and chief business development officer. Hi, Jonathan. How are you all?
Doing
Good.
great. How's everybody doing?
2 hours before the weekend. That way I'm good.
Yeah,
Let's say.
supposedly 2 hours before his vacation too, so we'll see about that. But
Yeah.
maybe I can
Yeah.
create some extra work for Sasha next week. Well, I'm very good at that.
No, please don't.
Yeah, so over the next 30 minutes or so, we're going to take a dive into an introduction to GPO audio. So let's jump right in. Jonathan and Sasha, thank you for joining us today once again. And let's start by talking about how you came up with the initial idea behind GPO audio.
Yeah, so I can tell you a story. Just several years ago, I originally started with another guy. His name is Basil Smatokin. He's actually the first guy in the company. Like he came up with the idea why we don't just use GPUs for running the plugins, and I never thought about that in the way like we need to bring some fundamental shifts to the industry, that we need to bring some fundamental innovation. And we started, like, originally he approached to me in 2011 maybe, and we tried some stuff in the past. We tried to build our own DAW back in the days. By the way, maybe this is the very first time I'm telling to you, to the audience, publicly. And we failed building the DAW because it was like .NET based, and the technology kind of sucked,
Mhm.
you know. But then we started over again with a new team, in 2015, I would say, with investors, with a new team, with professionals. We, in fact, right now there are more than 35 people involved in the company, and I guess there are 10 or 11 PhD engineers in our company, which is like indicating how fundamental and how hard this work we deliver to the industry is. And we started at 2015 once again, and we tried to build some kind of the engine that can run these audio related workloads for pretty much any use case, because we figured out this is way different to what is usually being as a use case for GPUs. Because, for example, when you do some gaming computing stuff, you do this usually with 60 frames per second, and higher than that it's like working with latencies as low as 16, 17 milliseconds. And in the audio, in the pro audio world, you work with less than 1 millisecond latency, right? You use this latency for the computing data transfers, for the entire round trip of data transfers. And this is way different to what GPU was designed for. And also, like, the user cases and user workflow and GPU workloads, they are absolutely different. So we started working on the technology how we can actually treat with GPU within 1 millisecond latency, and run in like hundreds or even thousands of independent channels with various DSP, digital sound processing or signal processing modules, like filters, various filters, FFTs, convolutions, even neural network layers, and so on. So we used to spend, like, from the 2015, I would say, to until the 2018. The whole story was a story of failures, and the technology uh, didn't didn't create it that easily. It took some time to figure out that it is not only about the GPUs. It is not only about how to run some specific software on the GPUs, but it is in fact all about designing algorithms mathematically, because 99% of the algorithms, DSP algorithms exist, there are not a good fit for GPU architecture. So they're in fact sequential in the traditional design. So we also brought the entire set of the algorithms. So we also made some fundamental work in the math field. We found some designs in some research papers uh, that provided us the ways to run IR filter look like transfer functions that could be a good fit for the GPUs and the other algorithms. So we used to spend a few years on that things, and we also spent another years to bring the entire technology stack. So the technology is as fundamental as the fundamental problems we solved so far. So you basically can have a quick look at Google NVIDIA GTC, the previous NVIDIA GTC. We were participants there, and you can just have just watch the you can just watch the session dedicated to the GPU audio technology and quickly realize that this is fundamental work we made. So now, today, we're at the point we want to, first of all, share with the world like what we have accomplished so far, because we are not just, I would say, plugin makers. In fact, we rolled out just a single plugin, which is the early access plugin, to test things out, to fix bugs, to fix issues. There are plenty of issues because there are so many hardware and software setups you guys have. So without you, we can't test it, and certainly without you, and certainly we can't test it all with our own hardware and software setups. So that's why we decided to run the early access program. And basically, we are, as I said, in fact, we are not just plugins making company. We are the next generation standard making company. There are various standards that exist. There are new standards that are coming. For example, CLAP. Kudos to you guys building the CLAP standard. This is a really good one. And we want to make this thing available to both users and to both businesses, and even indie level developers, I would say, so everybody can use it through the SDK or through the direct partnering with us, building some new products that that deliver new kind of workflow and user experience that lie beyond the traditional CPU-based and DSP-based use cases, such as spatial audio omni-channel processing. Like, you can easily process 64 channels within one instance. You can run it all on your $900 laptop with the RTX 3060 embedded, with the AMD 6000 mobile GPU chip embedded. You can also run neural network-based solution, machine learning solution, not just adaptive noise cancelers, but some kind of tone transfers. So this is like kind of the subject of AI-powered solution. So we are bringing the entire standard today, and we want to all of you guys, users, professionals, audio professionals, as well as developers, to come in and jump on board and to provide us with the feedback.
I thought I'd add like 2 cents to this, just because I thought it was interesting. Since the question is, how did they come up with the idea behind GPU audio? It's pretty cool. And maybe Sasha will get into it some other day, some other dollar, you know what I'm saying? But about how he's rooted in, as a computer scientist, working with low latency trading in GPUs. And it's just, to me, it's just so interesting to see how somebody like that has converged with Basil, who at the time, was also just a music producer, and their minds just kind of collided in this sort of epic nebula, ensued after that, and Basil's a super smart guy. He's actually our CPO now, coming up with all the ideas for the internal plugins and helping also, design other products that we're, going to be building with other people. Yeah, just wanted to add that.
Yeah.
Yeah, I mean, it's so cool. So let's dive deeper into the technology itself and how it actually works, like what makes it so revolutionary, and like you
Yeah.
talked about the mathematics behind it, the technology
Mhm.
behind it. So let's unbundle that a little bit.
Yeah. So, well, this is as I said, this is very fundamental. Usually, if you want to run just to code something for the GPUs, you usually start with some kind of shader languages or CUDA or any other frameworks and SDKs. And basically, all of these instruments that are available today, they are not really good fit to create any kind of program that you can use to run, I don't know, many various types of plugins together. And especially you can't run things with the 4 threads. Developers will understand this, 4 threads or 16 threads. So we dived very deep into this kind of problem, like how to bring pretty much any algorithm that used very tiny piece of data, because in fact, when you work within 1 millisecond latency at 96 kilohertz, is just 96 samples of data, right? For the left channel, for the right channel, for the stereo case. And you have to organize the entire data flow stack. In case you are building the plugin, you need to run many plugins in chains. For example, when you do some guitar party, you can easily involve like 4 effects together, like delay, I don't know, like reverberation, comp filter, distortion, this kind of stuff, running sequentially. And you can run like, I don't know, when you record a song, like 20, 30 tracks easily. So this is kind of the workflow that GPUs are not a good design, were not actually designed for. And we built the technology that allows you to combine all of the workloads and to transfer this to the GPU and to execute them effectively on the GPU. And there is a core technology, like a super program that was written with GPU assembler language for the NVIDIA GPUs. It's PDX ISA. Instruction set architecture for the AMD, we use GCN and RDNA to write some parts of the program that running all of those DSPs with all of the data transferred, running them together, managing various cache levels. There are various levels available on the GPU, running with uh, with different degree of parallelism, like 32 threads, 256 threads, or less, like just 4 threads, running them simultaneously within tiny amount of time. So we used to call this technology as a scheduler, because it's essentially what it does: schedule things on the GPU, making them dispatched within a certain amount of time, returning the results on time. And yeah, and this is how the data flow generally looks like. And the technology itself, it works on the 3 pillars. Like the one pillar is just the collection of the algorithms, DSP components that we designed and fit to the GPU architecture, so we can run them effectively, more effective than you can do this on the CPU, quite obviously. And the second pillar is that this scheduler program that allows you to effectively manage all of the effects running together, made of these DSP components. And the third part is kind of general technology stacks that allows you to organize the data flow, program things, whether you are actually building the VST plugin, or maybe in the future with our SDK, you would be able to build some kind of the clap plugin, or it's just a standalone app, not anyhow connected with the DAW, or you want to provide any sort of solution for broadcasting industry and you want to run things just on the Linux environment, you would be still able to code this stuff. So we brought all of this in order to, cover topics audio related, first of all, and then we started with the pro audio industry as like the very first one with the very first plugin, and we want to build the entire ecosystem of products.
Cool. I saw the second part of the question is asking, how is this different, or how does it compare, or how is it different in comparison to other solutions that are already on the market? I think the way that you have to look at it is, excuse me, what is the history of DSP acceleration? What has been the point of it? A lot of people have said, hey, this kind of feels like we're going full circle. Like we started out with dedicated DSP hardware, and then we moved away, and now certain plugin companies and developers are starting to focus more on native, especially on like the Mac M1 and M2 solutions. So why would we want to go to GPUs? There's a couple of answers to that. One of them, Sasha answered really elegantly the other day. I'm not sure if it's written down anywhere, but he talked about how the GPUs that we saw 5-10 years ago are definitely not the same GPUs that are in existence today. I think one thing to note is that we're basically capitalizing on an expanding market of like exponential gains in terms of GPU power, that's powering everything from like the future of robotics and AI, machine learning to video platforms and everything. I mean, there's GPU clouds, I guess you'd say, everywhere. And the power is so much more efficient. I think at the recent GTC conference, Jensen, the CEO of NVIDIA, mentioned that NVIDIA has increased computing power on GPUs by 1 million x, over the last decade. And so for me, it's really it's really not about how does this compare to other DSP solutions. This is like a fundamental innovation on the way that we process audio in general. So we're not trying to create like necessarily just a competitive DSP acceleration product, right? We're creating the foundation for people to accelerate DSP in parallel on GPUs from the ground up. So meaning that this technology is not just a DSP accelerator, this technology enables other people to build DSP accelerators and things like that. So again, we're dealing with like a really low level fundamental innovation on the technology, that we think is going to empower, people from plugin manufacturers to hardware companies and other people. But in general, if you're looking for like I think I also saw a question about like what kind of performance increase can we expect with like a 3080, graphics card, something like that, 3070, 3080 on a laptop. I mean, some of our console tests have been running, without the VST3 container up to like, maybe 2000 instances of convolution reverb, in real time, within 1 millisecond latency, or down to 150 microseconds is the lowest latency we offer right now to developers. So, typically we would say, with the VST3 container, it's probably more like 80 to 100 instances. And that's just a stress test, depending on the algorithm, you're going to see different levels of, performance increases. Sometimes it might be like, a 10x performance increase. Other times it might be a 100x performance increase. So it's not really possible to say, blanketly, here's 100 times better performance. It's going to depend on the algorithm you're using, the type of efficiency, and the way that it's going to be, the way that it's going to be integrated there. So in terms of how we're different, I think that's a big difference, is that our solution is just way more powerful than any of the other existing DSP acceleration options that are built on like Shark, chips and things like that. So it's definitely what I would consider a sea change in terms of the technology that's there. And the nice thing about it is that it's also different in the sense that it's not a walled garden ecosystem. This is a technology that's going to be able to be integrated across multiple platforms. So if you're a clap developer, which we're starting to talk to those guys now, yes, we want clap to be able to parallelize DSP on GPUs. If you're working with AAX, yes, we want to be able to parallelize that. So that's my answer to that, how we're different.
Yeah, for sure. And you kind of tapped into the latency. So I wanted to talk also a little bit about that. So how exactly were you able to solve the latency issues? Just because that was a huge issue for many companies that have tried doing that before, right?
Yeah. So probably I have to start again a little bit more broad to answer this question. I know that there are companies and individuals that tried this thing before, and that's why people are referring to this fact. Like there is a guy, his name is Nils Schneider. He already uh, released the GPU FIR kind of convolver over the internet. But the problem is that it worked with the 4K additional latency, I would say. Yeah, it was like 4K samples or something. And you can't run like more than five plugin instances together with this huge additional latency, because after that you can have a blue screen of death, and we know why. And there are other companies that try these things like acoustic audio, build some product. Liquid Sonics, I guess, they also tried to do something with the CUDA, and there were attempts of big companies that tried together with NVIDIA and AMD. There were some attempts, but they didn't publish this information. But we know that certainly we know why it is happening, like what are the fundamental issues with latency. So people usually think that, okay, GPUs are very latent because they were stick to this 60 hertz standard monitor refresh rate, right? And like there is no other way they can be low latent. In fact, guys, GPUs work through the bus, which is 99.9% is PCI Express bus. And starting with the PCI Express generation 3.0, you can pack up to 64 megabits per 1 millisecond, I guess, two sides. So that's how you can actually pack things, then dispatch things, and then return them back. So starting with the PCI Express 3.0 based GPUs, it was a game changer, like technologically. And we used to run things even on 700 series first, like our very first successful attempts to build some kind of low latency solution. It was these GPUs, NVIDIA GPUs 700 series. Now it's PCI Express 4.0, the actual standard. In 1 year or 1 year and a half, the market will make the transition to the PCI Express 5.0, and every single time we see these standards make the evolution in doubling amount of transfers. Don't mix those things like gigabits per second and giga transfers. This is a little bit different things, but they double like amount of transfer they do from one generation, or quadruple, I guess, from one generation to another one. So for us, it means that, okay, if we consider some kind of real-time work, whether it is live performance show or whether it is recording, and now with every new GPU, with the new PCI Express standard, you can pack more things together. So, and now without VST3 environment, because we have issues with implementation under VST3, we can run up to 2,000 of GPU FIR convolver instances or channels within 1 millisecond latency on RTX 3080. How about that? And like the more powerful GPU we have, the more things we can do at low latency. And the latencies or buffer lengths that are beyond real-time cases, like long buffers, or when you do rendering, we can do things in times and tens of times faster comparing with the CPU workloads.
For sure. Jonathan, do you have anything to add to that?
No, I think Sasha nailed it. Yeah.
There are so many questions. I'm continuously switching to the YouTube. And there are so
try not
many.
to look at the questions. We'll get to them soon. Yeah.
Okay.
Yeah.
No.
I know.
Yeah. Go ahead, Anouk, please.
Yeah, I mean, GPU Audio has an early access plugin. I also wanted to touch upon that. And how can we start out? What equipment do we need? Is there anything specific, any specific computer parameters that we need? Walk us through that a little bit.
Yeah, I can answer that one. So we took, by the way, early access was a big risk. I'm sure that other audio companies have done it in terms of actually releasing a product, like with a plugin, excuse me. But it was risky, and it was fun, and it was exciting. And we're really glad that we did it, because we've gotten to connect with like something like over 11,000 people, so far have signed up, and that just completely exceeded our expectations. We thought maybe we get like 250, 300 people to test it out, and then we moved to beta. But we decided to keep early access open, and the whole reason for that was we wanted to test this on as many configurations as possible, because one of the big things that developers come back to us with occasionally is, hey, how do we know this is going to work on these different driver combinations, or this driver with this hardware, and et cetera, et cetera. So that really is our main focus right now, is building that compatibility. So that's why early access exists. It's easy for people to get involved. All you need is a computer that's running Windows with an NVIDIA GPU for now, but within the next few days, hopefully, maybe a week, we're going to have the AMD GPU support rolled out. There is a particular issue with drivers that are older than like a year old. So, everyone needs to upgrade to the most recent driver on their GPU in order to get this working. The early access plugin was also designed hard coded for 96 kilohertz, 96 samples. That's for all the reasons that, Sasha mentioned earlier, is because we wanted to test those specific tolerances, because high res audio, fast sample rates and stuff like that. We wanted to make sure that this is working at that stage before rolling out, like a full-fledged feature set for all sample rates. So the next update to early access is going to fix the vast majority of the bugs that you guys have reported already. So anybody who wants to join early access can hop into the Discord, or they can go right away to gpu.audio, or no, earlyaccess.gpu.audio is the website, earlyaccess.gpu.audio. And there's a Discord link there as well. So there's been a number of bug fixes that have already come out. There's a bunch of known issues on certain DAWs. Different DAWs implement VST3s in different ways slightly. So that's a big reason why we're doing this early access. But yeah, as long as you've got a 10 series, GPU and up from NVIDIA, you should be good to go. The only DAWs that we're having, needing more time with to kind of get the compatibility wonderful is Bitwig Studio and FL Studio. Those two have some particular issues in regards to how they handle VST3 containers that are taking us a little bit longer, and we just want to dedicate some extra time before trying to roll out some kind of hacky, fix or anything like that. But pretty much all of the other DAWs that are out there, we even had people testing in DaVinci Resolve with some good results as well. Actually, that was somebody from NVIDIA that tested in DaVinci, and I was really nervous when they did that because it was live on a call, and he said, yeah, it works. So I breathed a sigh of relief and then added it to the list. So all documentation on the early access stuff will be updated super, super soon. So that's my answer for that one right there.
Yeah, I would also prefer to pick up one particular question, if you don't mind, Anouk. So
of course.
I noticed,
yeah, I was about to dive right into them.
Okay, so there are many questions. So I particularly want to address this specific one. So is there a way to monitor GPU loading real time while using a DAW with GPU-enabled VSTs, like monitoring CPU loading? This is a very good question. So the way GPU counters work in pretty much any operating system, they just count driver API calls. Like if you are just making lots of data transfers, they count like your GPU is busy. There is no, direct way of operating system asking GPU like how heavy you are loaded with any workload, and there's no precise measurement on that. So that's why in Task Manager on Windows, and probably in the Mac OS X version, M1 GPU-based version, in Activity Monitor, you will not see the real picture with the standard instruments, never, because they are all relying on some kind of, I don't know, approximate driver calls-based approach. I'm not sure. We plan to make our own performance monitor, because ultimately we know how much of resources do we consume on the side of the GPU when working with a given workload. So that's why we think that with the time we can implement some kind of the monitor that will be placed, I don't know, somewhere near to your bottom right, typically bottom right part of the screen near to watches and dates and this kind of stuff. So you always see like how much of GPU power you still have. This is this kind of that approach we want to take when actually measuring the performance, latency, this kind of stuff. But currently there is no direct way to measure it, and there is no instrument that can give you with a right picture. MSI tool, I'm not sure whether it is MSI Afterburner or something. Any operating system based tools there are they're run at that. So please don't refer to them, and we still don't have the solution for it. Okay, Anouk, may I kindly ask you to bring any other question pretty
Yeah, I
randomly?
was about to head. I think now is a great time to start the Q&A session. So guys, if you have
Okay.
any more questions, feel free to comment
Mhm.
and we'll
Cool.
definitely answer them. But I see a lot of questions asking kind of about the future, asking about the beta, whether we're going to be rolling out a DAW. And
Right.
so I want to ask a question that Gerard posted. He asked, this has the potential to explode once you secure the first big plugin developer. How confident are you of getting the big plugin developers on board? So let's talk about that.
Man, I mean, we're pretty confident on the conversations we've had so far. I mean, there's a lot of we've got hit up by so many people, and we've reached out to so many people, and a lot of them have actually known our story for at least a year, maybe 2 years, maybe longer in some cases. So a lot of these big plugin developers in like the top 20, top 10 have been aware of what's going on with GPU audio for some time, kind of waiting for this opportunity. Yeah, that's all I can say is that yes, it's going to explode, and it's not a matter of if, but it's a matter of when these plugin developers choose to engage with the tech stack. I can't really reveal, and this addresses another question potentially that somebody might have. We can't really reveal a lot of the names of the people that we're talking to, obviously, just because there's a lot of NDAs and stuff involved, because there's a lot of technology that's being discussed in detail. So we want to respect those wishes from the clients. But yeah, we think it's going to blow up, and we think people are really interested. I mean, we've had a lot of companies in that top 10 category talking with us about the possibilities. What I find really interesting about the partners is how some of them they all see it in slightly different ways. Some of them see it as a potential to roll out products that you've never seen before, products that weren't really possible in the past. That kind of blue sky thinking gets me really excited in particular. And then we've got other companies that are looking at this as a way to basically power up some of their existing libraries and stuff like that, so that a lot of the basics can be taken care of, and then it can save their CPU for some of the heavier plugins that they've already designed for CPU. So it just depends on the use case, on which client that we're talking to, on where they want to go with it.
For sure, for sure. And we have a bunch of different questions, but Pim van der Vliet, I'm sorry if I butchered that, from YouTube asked, will developing with GPU audio be a similar experience difficulty as developing in, for example, Juice? We actually, just a quick note, we actually did an interview with Juice during NAMM. So if you want to check that out,
Yeah,
go
that
to
was
our
really
YouTube
cool.
channel. But yeah, let's address this question.
Yeah, so actually I was literally typing the answer to this question, and I submitted
really?
to YouTube channel. But anyways,
Talking is
yeah,
better.
I want to provide some detail on that. So yeah, so basically the SDK, I can speak about our SDK from at this moment. So we want to provide you SDK that is kind of layered SDK. There will be a layer of writing like writing the code for the GPU itself. Like you can do even things beyond the Pro Audio, which is basically just digital signal processing things using our own collection of DSP methods that were parallelized for you guys. And the way it will work for you as probably as that, if you guys know what's the Thrust library, like very popular library for the GPU developers, you are not managing parallelism or parallelizing code. You don't manage threads and blocks. You just call some DSP methods and they work. Like if you need the FFT, this works for you just the same way, whether you call it from your CPU code or from your GPU code. So we want to provide you this level of comfortability when working with this part of the SDK. Another part of the SDK is more like, okay, I built something that work on the device. Now I want to connect it to some kind of environment, right? Current connectors with environments, we would call this that way, is just with the VST3, and it works with the DOS, obviously, that supports VST3. We assume that with the time, we want to connect through the different interfaces because the VST3 has its own issues. I mean, third-party developers issues that we also faced when developing VST3 plugin or plugin subsystem. And basically, if you want to connect this device code with the VST3 environment and provide with the GUI, provide with the controller and all of the stuff, just register your device code as a plugin, as a VST3 plugin or VST3 plugin that could be used in a chain with the other VST3 plugins. We will provide you with this kind of wrapper, bridging, I don't know how to call it, developer instruments. So this is another layer of the SDK. So it looks pretty much similar to Juicy development or VST3 based development. It's like kind of the same. And there are additional things that we also want to provide you as a part of the SDK or like optional parts of the SDK. Actually, this is, to be honest, this is one of the good things about us, because I know how the development look like for the other companies that work in the industry. There are companies that use, for example, OpenGL to render the GUI, which for me looks a little bit crazy. Like you have to hire the GPU guy to render just knobs, and to bring like this kind of GUI, this kind of photorealistic experience of the GUI, just hiring GPU guys to code it. This, for me, it sounds crazy. And there are certain companies that figured out how to easily build the cross-platform applications with just writing web code through the Qt library or Chromium. So you basically write like JS app with a sprites library or with vector graphics. There are plenty of libraries available, and you just send the data from the web application to the server that is hosted within the plugin. This is the way you can connect the editor with the controller, speaking VST3 wise. And we want to provide you with our own collection of methods. You can build your GUI just a matter of weeks. And it doesn't matter what it is. Is it just charts, a synthesizer, or you want to build like 3D space stuff for spatial audio using 3GS library? It doesn't matter. You can do it all. And we want to provide you this optional SDK layer to build the GUIs. And there are other things like you can run GPU processing, real-time processing over the network, just TCP/IP based network, and this can work within 1 millisecond latency. This is another model you can connect. So this is like pretty much C++ standard development, and the device part of the development will look like very simple. You will use just very standard DSP methods. There is no mathematical magic that will be open for you, so you shouldn't handle this. But in case you want to bring your own GPU implementation of the methods, you will be very welcome, and you will be able to do that still. I guess that developers learned a lot about the future SDK, because I really provided some details on the development, the future development case.
Mm-hmm.
Okay, let's move on.
Yeah, there's so many questions I can't keep up. But the Amiga Man the Megaman1 from YouTube is asking, in comparison to Avid HDX cards, how many times more powerful would you say an RTX 3080 be? Will a DAW be an actual competitor or more of a showcase? Ooh.
Yeah,
There's two
so
questions there. I'll let Sasha take the HDX one, and I'll take the DAW question.
good point. Okay, so comparing with HDX, there are two faults here. The one is like hardware capabilities, and GPUs are incredibly more powerful with any Avid stuff ever made. Well, this is because NVIDIA has all NVIDIA and AMD and now Intel and Apple. They all have their kind of budgets on research and development, right? We all sponsor them when we purchase their hardware. So this is like theoretically it's hundreds of times, right? But when it comes to reality, to real implementations, currently it's 10 tenths of access, not more than that, because we have limitations on plugin side development. Like we can run certain algorithms that could be equivalent of Avid Pro Tools based plugins, I would say. They mentioned they can run like up to 64 channels HDX, one single card HDX. I'm not sure how many it is it now. And well, we can run thousands of convolutions, and in the VST3 free environment. Within the VST3 environment, current level of performance is limited, very limited to the 100 or 200 or so instances. So we are working on actually fixing that. But yeah, it's basically it's tens of times. It just depends on various things like hardware setup, software setup, audio project setup, because like you can run things on 96 kilohertz, and samples you can run things differently. We have our DSP methods designed with various degree parallelism degree, like 32 threads or 16 threads or 256 threads, depending on what kind of the product you are using and what kind of the DSP components that are part of this product. We have different boost, so it's super hard question. Like for the heavy processings, we can boost up to tens of times. For the not heavy things, we can I would say we are not boosting it at all. We just can run them, many of them, like delays are very simple. IR filters there, they used to run with 4 8 threads, and with RTX 3080 that has like thousands of cores, you can run literally thousands of delays. But I'm not sure whether you guys need these
Yeah,
things.
so to me that kind of like that's one thing that people bring up a lot, is like, okay, with certain algorithms, are you really boosting them or what? And it's like, okay, the point of GPU
Yeah.
audio is not just to accelerate things, but it's actually to create a situation in which if you're offloading to the GPU, then you can handle a lot of basic things, in just without stacking latency up as you go, because we're running them in parallel and they're not clogging up your CPU. So for some users, they like to actually, just use more of like the basic stuff, I think, in the future, and then save their CPU for other things. But yeah, I think, okay, so the other part of that question was, will the DAW be an actual competitor or more of a showcase? I mean, I guess you'd say it's a bit of both. We can't really say a whole lot about it for right now. I mean, I guess you could call it a DAW. I think basically it's going to be its own revolutionary platform, if I can say that. I really strongly believe in it, and we're going to release more info about it as we go. But I think you guys are going to really love it, and I'm sure it's going to inspire a lot of people out there. So yeah, sorry I can't say more about that yet. Anouk?
Yeah, there's definitely more updates to come. I feel like Discord is a great place to follow up on any updates, just kind of chat. But yeah, so Ben on YouTube is asking about convolution seems to be a good fit for GPU processing? What other audio processes are a good fit, and more importantly, which ones aren't? Or is GPU a magic solution for all audio tasks?
Yeah, very good question. Thank you for that. This is kind of the question that developer will ask. So yeah, as I said, we partially found some designs of the DSP algorithms as, for example, as IR filter. We didn't parallelize IR filter because there is no way you can parallelize purely sequential code, right? But the IR filter, it has its own transfer function that this, how to say, makes this filter unique, right? You can find, I would say, you can find the other filter that, from the transfer function perspective, can provide you the same output to input, kind of the law, output depends on the input. And this design could be a really good fit for the GPUs. So answering the question, we either found designs while reading the papers. And this is my comment to FabFilter founder, because he doesn't know about that. And we also uh, made our own designs of the certain DSP components, the other types of filters, the other even approaches to build some kind of DSP specific things. Like in compressors, there's a detector component, right? And detector, basically what it does, it has to find the sample that is above or below some kind of the level that you're looking at, and you want them to apply some attack or release mode, right? So from the very, like from the very first approach, you'll think that, okay, I have to make a sequential search, but there are plenty of search algorithms that's available in the parallel design, and you can do this in parallel. So all of those DSP components, whether it is just pure maths, it is filter related, or not filter related, it's something else. We have them all parallelized uh, and collected as a set of the methods you can use. So it is not just GPU FIR convolver we rolled out and said like, okay, now we nailed the GPU audio. No, as I said, we have the entire collection that is enough to build pretty much any standard software that you ever experienced in the pro audio world before the GPU audio. And yes, because we unlocked your GPUs for the pro audio workflows, now we can build things beyond that, beyond the traditional DSP products, an approach that is taken to build the products. We can run some things with the CUDA backend. We can run neural networks computing far more effectively that you can do with PyTorch or TensorFlow, and we can run them with low latencies, because now it is not. And the products that exist that still using some kind of machine learning, they are not doing that. They just used to pre-train things, and then they used a little of power, comparably a little of power, to just process the input buffer with a pre-trained model by simply multiplying things. And we can do like continuous training kind of neural network approach with the GPU audio, unlike this kind of building this kind of products. And we also can do things beyond that, like spatial audio and more and more and more things. So again, this is not just accelerating, this is unlocking your GPU to do things that you couldn't do without it. So yeah, and you can do this with all of the methods that we will make available with our SDK.
So we have a quick question about the differences between VST1, VST2, and VST3 from Fact of Reality TV on YouTube. And the question is, has there been a wrapper tunnel or insert tested between those? And so what were the results?
Jonathan, would you take this question?
Well, what I think the best way to answer that is just by saying we're focusing on VST3 for obvious reasons, which I think Fact of Reality TV will probably understand if you're already developing things. It's just it's a better wrapper for us. It's a better place to be doing this. But beyond that, we're not so interested in really expanding the different VST formats. I mean, we are doing some VSTi, which is really cool. But we're also interested in expanding into other things. So probably our next focus really is audio units, like the most recent audio unit. We just spoke with Apple about that and getting that implemented for M1 and M2. Got technical conversations moving. It's going well. And then in addition to the audio units, we just started talking to the guys at Clap. Really excited to see what we can do there. Hopefully Clap's going to be less bloated and less crazy than working with VST3 compatibility. And then, also AAX is something that we're exploring too. And the reason so is because we think that these other formats are actually going to be less limited, than the VST3, and you inevitably get better results from those anyways. So that's sort of my best answer to that. Sorry if it's not exactly what you want, but there you go.
Yeah, and since we're speaking about updates, new rollouts, just everything that's coming up, I feel like a lot of people are anticipating AMD.
Right.
And yeah, so Miguel from YouTube is asking whether there are any updates about AMD.
Yeah, so I was diving. I went into our internal channels to check with all the engineers, and they did the little sweat brow, the little sweat face, and said, "Hey, we're working on it really fast." But essentially, what we did is, so the early access plugin was originally developed with, I guess you could almost call it like a hacky version of our implementation. So, we're not using like our GUI design, we're not using quite a bit of elements from our actual SDK. So what we did is, instead of trying to update on that, we didn't want to cause redundancies, in engineering that would take, extra time. So we actually ported the early access over to use our actual SDK, which means that plugin will eventually find its way into the full ecosystem, which is great because it's become something of like a cult, classic with people making cool videos with it and stuff. But also what it means is that AMD support is going to be like way more rock solid and reliable, and it's going to be something that's going to work into our full SDK. So Miguel, I'm sorry, my friend, but it's going to be like a few more days, maybe a week. I think it was originally projected to be last weekend, and then they told me, hey, give us like another 2 weeks max. So the last update I got from the team was yesterday, and I'm hoping that we see it by the end of this coming week. So stay hanging in there, man. Like we're working for you.
Yeah, we're working for you, man. And for the other guys too, I would also add some 2 cents from my end. So the reason why it took a little bit more time, because we are really making things that the others didn't do. I love to say that, but also I want to let you know that the bringing AMD version was not possible without direct collaboration with the AMD guys. And thanks and kudos for them, because they fixed some things that without those things we wouldn't be able to bring the core tech, which is the scheduler on the device side. And also we used a very tricky way to build our kind of products or processors, speaking VST3 wise, processors which made of these DSP components, because we didn't want to code the OpenCL, like writing a C code at 2020 second. It's like a big big challenge, I would say. So that's why we wanted to stick to the CUDA C++ approach, and just to find the way to build the same code for the AMD GPU, targeting AMD GPU devices. And we found out, and we also worked with AMD, and they provide us some specific updates. They provide us specific library upfront. They didn't publish this library on the GitHub, and we used to create the binaries for AMD. So we reused the same NVIDIA CUDA C++ code that we wrote to build the AMD GPU binaries. And this is the same approach that you guys third-party developers, future GPU audio developers. You will also work with the most popular, the most available, the most like free to use developing environment to build the same code for the various platforms. Because believe me, in fact, NVIDIA and AMD GPUs, they may look similar, but underneath at the assembler level, there are different, and there are things that we are making work for you guys. So because of all of that facts that you don't know, because there are like bottlenecking things we need to anyways, because we are developers of the technology, we need to solve them first. We've solved that. So that's why it took some time to actually bring AMD support to the early access GPU FIR controller. But stay tuned, 1 week, maximum 2. I don't want to promise, but I feel like we will roll this out.
Yeah, it
Yeah,
seems
it's
like
coming.
it's moving
It's
fast.
coming.
I can address like a follow-up question that had specifically to do with that too, or at least was related to the SDK part of that conversation. Talking about Juice, people are asking about Juice. So we actually had a meeting with the founders of Juice. Anouk was kind enough to interview Bobby, who's head of their developer or like their partnerships and business development and stuff. Really cool guy, great interview.
Such a great guy. Yeah, such a great conversation.
He's super positive on GPU audio. He's GPU positive. You know what I mean? I guess I would say. And I love that. We had talks about ADC. Obviously, we have to apply like everybody does. But I feel pretty confident that we could get through that gatekeeper process and actually present this at ADC. And if our SDK is available in time and everything's kind of like syncing up, then I'm hoping that we can actually give live workshops with people, with developers interested in using parallelization on GPUs. So similar conversations with AES. There's like at least 3 AES scheduled appearances, one at Latin America. For anybody in Latin America, shout out. We're going to do it in Argentina. That's going to be really cool. We're also going to be doing more AES stuff that I can't mention just yet because it's not on the books officially, but it's going to happen. And then also NVIDIA GTC. The next GTC is a very real possibility as well. We're just submitting all the abstracts and papers. So, by the way, can anybody in the chat, anybody who's a developer, can you just type 1? Like just put a 1 in the chat. I'll show you how. Just ding. I'm just kind of curious, who we're talking to. It seems like we got a lot of developers here. So, yeah, if you don't mind, drop a 1 in the chat if you're a dev. And Anouk, you can go ahead and give us the next question.
Yeah, so Andy Wilson from YouTube is asking, how does this relate to ASIO and low latency audio for Windows? So we're kind of jumping back into the low latency one.
Yeah, so I actually didn't get the question. I read this question, but I didn't get. Can you please elaborate what's the specific question behind that?
And while we wait for that, yeah, since we're on the topic of updates, Mikhail Kapoliani, I'm so sorry, is asking whether Linux support is being planned in the future.
Yes. Yeah, so I basically replied to this question in the chat already, and the answer is that we are building all of the components cross-platform, cross-compatible in many ways as many ways as possible, and we just didn't, we didn't pack some files speaking CI/CD wise, and we didn't prepare the binaries for the Linux. We still have some kind of hard-coded things for the Windows only, but we are getting rid of that, and we want to, speaking specifically, we have some threads management, which uses some Windows-based primitives, but we are getting rid of that. Once we will do this transition, we will be physically able to provide of some kind of the binaries that could be run under the Linux. And if you want to make this earlier, you have to, make initiative and see all Linux-based guys somewhere speaking to us like, please bring the Linux, because if there are three guys, well, we have to prioritize this less. I'm sorry, because we are not like 2000 employee company, right? And if there is some initiative and we understand that people need it, we can bring this earlier. So it is on the list, but it is not in a high priority. We have Mac OS X ecosystem to bring on, and this is one of the top priorities. Uh, Top priorities, both supporting the M1 GPUs, M2 GPUs, M Silicon GPUs, as well as Mac OS X operating system support and audio unit format as well.
And staying on the topic of updates, Thomas is asking, will GPU audio plugins be in AAX format too?
Right on. So I sort of mentioned it a second ago, sort of in passing, but I can be more clear. So we had a really amicable conversation with Avid about AAX support. They said that they're a fan of us supporting it. So it's kind of like a handshake and agreement. Like, hey, yeah, this seems like a no-brainer to allow AAX to be supported by GPU audio implementation. So yeah, we're looking forward to starting on that project. And yeah, we like I said, I think that we're going to see much better performance gains on that versus VST3. So stay tuned. For now, if you're using Pro Tools, when the beta comes out, like end of month or in July, probably more like in July, when those beta plugin bundles begin to be released, the best bet is to basically use a wrapper or a container, like what is like Plugin Doctor, Blue something, those other kind of Pro Tools VST3 wrappers is what I would recommend for now. Oh, and I did see on the topic of updates and stuff, people who want to use like 900 series graphics cards, like the GTX 960. I think that was also from Thomas and Digi's Dungeon. So those cards they're just like right on the cusp of being too old to really see the kind of performance that we're looking at. I would say the 10 series and up is going to be your best bet. Doesn't have to be an RTX card, but it does, basically need to be a 10 series card. Some people did report that they got their 900 series GTXs working. But I just don't see us as performing like, massive updates to continue to support those cards in the long run, over a period of years. But for now, you can certainly test it out on there and see if it works. But man, the prices on 10 series cards are so low right now.
Yeah,
I'm seeing like 1080s and stuff on Craigslist or OfferUp, for like a couple $100 out here in California. So, if I were you, I'd just maybe make the upgrade.
I can also provide you with the insight that basically we use in the core technology we use CUDA 5 point something. So it is supported with PCI Express 3.0 devices. So we might probably run things for 800 series and maybe even 790 or something. I'm not sure. I have to check. But we just didn't build this for these old GPUs because it doesn't make too much of sense. They can provide you with the same feeling like they are powerful because they consume a lot of power and they have a huge TDP or something. But when we do GPU audio processing, we are currently relying pretty heavily on CUDA Alu cores. Like you have to count how many CUDA cores you have, multiply it on the standard frequency, the boost one. So this is two things that can provide you with the vision whether your GPU is a good fit for the GPU audio or it's not. So if you have a look at the previous gen GPUs, there are not so many CUDA cores available, like 2,000, 4,000 maximum for the Titan V or something. 6,000, I'm not sure.
Yeah, we actually got a nice comment from somebody named Dr. Tenma in our Discord, and he provided a link actually to a Wikipedia article that has the GPU, like basically lists the GPUs of the generation that we're sort of aiming for and up. So if you guys want, by the way, please subscribe to the channel here because we're going to do lives every week. We're going to have lots of other guests and stuff. But if you go to our videos, the most recent early access update, volume 2, is going to be the one where there is a link in the description for that Wikipedia page where you can kind of look at some of those GPUs. And we'll make sure that it's the right thing too. But that basically corroborates with what Sasha described right now as well.
Yeah, one more thing about the updates. So because this new version of the GPU FIR convolver will include some parts of the core technology that were not cut and limited as we did for the previous version, we will provide you with a better single GPU support. For me, it's hell a lot of efforts we put there in order to make it, in order to make it happen. For you guys, it is an ability to run GPU FIR convolvers together at low latencies, especially together with any other software, whether it is some kind of the game or OBS or something like that. And for us, it is another ability to bring GPU audio as a core engine to other environments like Unreal Engine, like I just forgot the name of the second one that is used to develop games. Sorry, guys. So we can run things together simultaneously, and we can run things with low latencies, with heavy workloads. Doesn't matter. Now with this update and with the following updates, we'll provide better single GPU system, single in terms of your hardware setup, like you have the only GPU, as well as running all of the processes on the same GPU. You can have another one. So this is in the both meanings.
For sure. And so before we wrap up, there's a question I also want to address. So we have a question that says, any DSP domain-specific language already supported?
I know why people are asking this. So we have talks with the Faust developers. We also have spoken with the other guys. For now, we don't do any kind of implementations for DSP languages, because if we want to provide kind of native implementation for those languages, it is a little bit painful, because we need to bring our DSP primitives and our internal implementations in the way they could be reused in these DSP languages, I would say. So you can not just building cascades of filters, but you can go down deeper and tune, filter banks or something, making some new things using these DSP language primitives. And this is a very hard thing, and fundamental problems that lie behind this background are so hard, and almost nobody solved them. Like, I would say, this is all about paralyzing things, and this is all about compiler techniques, and the problems were not solved since 70s. Like, I was not born at the dates these problems were mathematically described, and this is why when I spoke with the Faust guys, I told them that basically it is near to impossible to bring some stable version that could be, DSP language that could use GPUs as a target platform, and this could be extended with the time. This will be a real pain, because parallelizing every particular DSP method requires a very certain mathematical field knowledge that could be not connected with DSP anyhow. Like FFT, famous Kulituki implementation with all of the enhancements. Sorry, guys, it's not DSP method. Like, there are things from the classic math should be concerned here. And that's why I told to Faust guys, and this is what I want to address to the other guys, that kind of bring in some more nicer way to build some DSP things, like more native language approach. We can bring some kind of interoperability Like you connect some library through the SDK, you have some API, you have some methods, you can essentially use them. You can provide your own implementation, your own methods, and you can use them combined to build something, but it will be C++. Sorry, guys. Like we can target very certain ways how to build the product, and we are not going to support DSP programming languages because it is just another story, and I would say another standard. We can't support them all. Now we are doing just so many things. Like we are bringing support of the various hardwares, the different hardware. We are bringing some environment of different hardware that is literally huge pain. If any of you guys ever experienced driver development or driver level development, you will instantly understand what is the background, how is it painful, and we are bringing all of them together for ourselves and then for you guys in the SDK format to make it, you know, be reusable, I would say. And this is our main goal, and we need to deliver these things first. And maybe with the time we can speak about bringing something to the DSP languages, but I don't think personally that it is a good way to think about. I think like bringing some interoperability layers to some DSP languages is certainly the easiest way to go. And this is certainly could be done by DSP programming language developers on their own using our own SDK. So I think this is definitely the best approach here.
Yeah.
And not only that, but the interactions with with Juice, specifically now, and then we're still messaging people from Clap and everything. I think it's going to be hopefully, like, what we would definitely like to see is people that are working in Juice be able to continue working in Juice. People who are working in Clap continue working with Clap. And then just have the option, like, okay, for this particular plugin, I want to actually parallelize this on GPUs. We want that to kind of be a part of the thought process. We want it to be like a simple train of thought from, like, the project that you're designing, figuring out if the best use case would be running it on GPU, and then being able to implement that simply. So that's the huge focus of the SDK. So, by the way, if you guys want to sign up for the SDK, the easiest way to do that, is to go to gpu.audio/SDK. It's gpu.audio/SDK. And that's going to be the sign up form. That's going to only sign you up for that particular form. So if you don't want to get updates on other stuff, then, oh yeah, I see Alexander says his brain is dying. Yeah. If you only want to sign up for the SDK updates, or if you only want to sign up for the Mac OS updates, there's a link for that. We're trying to make it simple so people don't get spammed, and then we don't accidentally churn emails, mistakenly by offending people. So, but yeah, thank you. I see all the other comments here, about Acoustica Audio, all these other things. Unfortunately, we are kind of out of time because our team running the StreamYard stream needs to go, to their next appointment. But, on behalf of myself, I want to say thank you. You guys are amazing. I'm really happy to see so many people join this live stream. So thank you very much. And no, we're actually not based in Switzerland primarily. That's where we're incorporated, but we are a global company. So people are all over the place.
Yeah.
But our office is there. Yes, correct.
Yeah, we have 13 geographies and we have 35 plus talents pretty much everywhere: UK, US, Austria, Bulgaria, Armenia. I'm sitting in Dubai, guys. Like it's fully remote.
I'm in Orange County. Yeah.
Yeah.
It's crazy.
Yeah. So
but yeah, thank you, everybody.
Guys. Yeah, we're here, guys, as GPU Audio. We're here for all of you guys, for users, for professionals, enthusiasts, for companies that want to build something powered with GPU. We're all here to serve you because our mission is to make the next generation standard that can power up things that we didn't see before us, and we want to make it available for everybody. So we are not building any walled garden. We are open for all of you guys. So if you have any ideas, if you have any proposals, please feel free to share it in our Discord community. If you don't know this, just follow gpu.audio website, to the very bottom. Just click join the Discord and feel free to share anything you have in your mind. Thank you, guys. Thank
Yeah,
you.
thank you so much. Thank you for joining us here today. Thank you to Sasha and Jonathan for also joining us here today and answering all of the questions. It was super great. We will continue to answer all of your questions in the comments. You could also, as Sasha already mentioned, join our Discord. And yeah, once again, thank you so much, and subscribe to our YouTube, just because we're going to be having a lot of events with a lot of different people. So
Thank you. Bye bye, guys. Cheers.
See you guys, everybody.